Hi, in this video I'm going to explain how to make, add, and subtract matrices. For today there are two important questions. First, how can we use a matrix to represent real-world data? Second, if we have a pair of matrices, how can we add or subtract them? So what are matrices for? First, I just want to clarify that the English word matrix means one, and if we're talking about many, then we use the word matrices, not matrices. And I'm going to use this sign for matrix. So what does a matrix mean? A matrix is a way to organize some data from some real-world situation. So if we're comparing costs of rent, food, and utilities in two cities, Boston and New York, for example, we can have this table to represent our data with 2 rows and 3 columns. But we can also represent all that information in one matrix. So we just take those numbers and move them down in an organized way into a matrix with 2 rows and 3 columns. That's all a matrix is. So what's the point of this? Why is this any better than having a table like we started with? For right now, just for organizing the data, there's not much of a difference. But later, if you want to do any kind of operation on a matrix, like add, subtract, or multiply, it'll be much easier to use a matrix than to have the information stored in a table. The way we describe the size of a matrix is by the number of rows and the number of columns. So this matrix here has 2 rows and 3 columns. So we call that a 2 by 3 matrix. We write it like this, 2x3. If we had a matrix with 4 rows and 6 columns, we'd call that a 4 by 6 matrix. And the reason that matrix size is important is because if we want to add or subtract 2 matrices, they have to be the same size. So for example, we could have a 2 by 3 matrix and another 2 by 3, and we could add those. If we had a 2 by 3 and a 4 by 6, we would not be able to add those matrices. So here you can see we've got these 2 by 3 matrices, and we want to add them. So the way to do that is to add each corresponding element. So for example, you can see these highlighted in blue elements. The first row and first column of each matrix. We've got a 5 and a 1, so we're going to add 5 and 1, and that will be the first item in the new matrix. And so on. So the top row, second column of our 2 matrices that we're adding are 4 and -4, so we'll add those and that will be the item in the top row, second column of the sum. And 0 plus 3 will be the last element in the top row. For the bottom row, we'll do the same thing. We'll add the first element of each matrix, the second and the third, and put them into that corresponding position in our new matrix. And the last step, of course, will be to actually add each of these pairs of numbers. So you see the answer that we've come up with here is once again a 2 by 3 matrix. It's the same size as the 2 matrices that we added. Subtracting matrices works just the same way. Keep an eye out for possible double negatives popping up and just be careful with those. So in this example, we've got our green highlighted elements, 10 and 7, so we'll have 10 minus 7 in the final matrix. 7 and -4 are highlighted in blue, so that'll be 7 minus -4, which will then be 7 plus 4. And the third element in the top row, -11 and 20, will give us -11 minus 20 in the final matrix. And then for the bottom row, we'll just do the same thing. We'll pair up those corresponding elements and subtract them. And then, of course, the last step will be to actually subtract those pairs of numbers. And once again, you can see that the answer we come up with is the same size as the two matrices that we subtracted. That's it for this video. Thank you for watching. I hope you enjoyed. I hope you learned something. Have a great day.